All right, welcome to our masterclass on one of the most critical and honestly one of the most misunderstood material certifications out there. If you're someone who specifies, supplies, or installs metallic products for any kind of safety-critical application, then you know that understanding EN 1024 Type 3.2 isn't just nice to know, it's absolutely essential. From the moment a ladle chemical analysis is done at the mill all the way to the final torque on a bolt at a job site, that unbroken chain of traceability, it's the real backbone of industrial safety, especially for components that fall under big directives like the Pressure Equipment Directive, or PED. Proving that material's integrity isn't a suggestion, it's a non-negotiable legal requirement.
But here's the big question we're tackling today. What happens when you have a perfectly good, certified product sitting in stock, but your client suddenly requires the absolute highest level of third-party validation after the fact? This is where we really have to get clear on the difference between getting certified at the source versus validating it later on.
Okay, so let's dive right in. To really get a handle on the solution, we first got to understand the standard itself and, why it carries so much weight in our industry. So EN 1024 is basically the European rulebook for inspection documents. You can think of it as the system that gives us concrete proof that a metallic product, whether it's a plate, a bar, or a fastener, has the exact chemical and mechanical properties that were ordered. It's truly the foundation of engineering assurance.
Now, what's really fascinating here is how the standard has evolved. Back in the 1991 version, the highest level of third-party certification actually had a different name. But the 2004 updates streamlined things, and it redesignated that top tier as Type 3.2. Knowing this bit of history is so important, especially if you're ever looking at older project specs that might still reference that old standard.
And that brings us right to the heart of this masterclass. See, it's not enough to just ask for 3.2. You have to understand the massive difference between a true 3.2 certificate and one that meets the intent of 3.2. Trust me, they are not the same thing.
This table just lays it all out perfectly. A true Type 3.2 is born right at the source, at the mill or the forger. This is what you get when you have operations that actually change the material's properties, like forging or heat treating. The manufacturer does their tests, and an independent third party is right there to witness them and co-sign the certificate. Now, on the other hand, an intentive 3.2 is a totally different beast. It's a retroactive process, usually started by a stockist for finished goods. They begin with a solid EN 10204 Type 3.1 cert as their starting point, and then they bring in a third party to validate the material through a whole new inspection. So here's the key takeaway. True 3.2 is proactive. It's built right into the manufacturing process from the very start. Intentive 3.2 is reactive. It's a super robust, very rigorous validation process that you apply to finished products that are already sitting on the warehouse shelf. So let's get into the nitty-gritty. How is this retroactive validation actually done? I can tell you this is no simple paperwork shuffle. It is a methodical, step-by-step inspection designed to give everyone the highest possible level of confidence.
And the whole thing, the entire process, it all hinges on this one single principle: maintaining that unbroken chain of traceability. The number one job of the third-party inspector is to prove with cold, hard evidence that the physical item right in front of them is the exact same item that's described on that original mill certificate. No gaps, no questions, no doubts. It happens in 3 really strict stages. First up, Stage 1, material identification. A surveyor physically goes to the stockist, does visual and dimensional checks against that baseline 3.1 cert, and then applies a unique test stamp marking to the samples they pick for destructive testing. That mark is key for traceability. Then, Stage 2, witness testing. The surveyor is physically present to witness all the required mechanical tests. We're talking tensile strength, impacts, hardness, at an independent or accredited lab. And finally, Stage 3, final review and release. After going over every single piece of paper and all the test results, the surveyor does one last inspection and applies an indelible hard stamp right onto the material itself. That stamp is the green light, releasing it for shipment. Okay, the theory is great, right? But let's look at how this actually plays out in the real world. We're going to take a look at a case study with Andrews Fasteners, a specialist distributor that does this exact process day in and day out. Andrews Fasteners is just a perfect example of a company managing this process. Their bread and butter is finished products like CE and UKCA marked fasteners. Things like BS EN 1439 for preload assemblies or BS EN 15048 for non-preload.
Because the work they do doesn't actually alter the material's properties, the intent of 3.2 route is the absolutely correct path for them to get that higher-level cert for their customers.
And it all starts with their rock-solid quality system, which is registered to BSE and ISO 9001 and NHSS 3. That gives them the framework they need. They take the existing EN 10204 3.1 MIL certificates as the baseline for every single part. And it's that solid foundation that lets them use their own in-house testing facility for the validation, all while being supervised by an accredited third party.
Yeah, that independent validation is the secret sauce. They partner with an accredited body like LRQA to witness the whole process. That guarantees total objectivity. And it's also worth noting that while they're experts at this retroactive intensive 3.2 process for their stock, they can also arrange for brand new products to be made to full true 3.2 specs from the get-go with their manufacturing partners.
Okay, this brings us to what might just be the most important rule in this whole thing: total, absolute transparency in getting approval beforehand.
The standard could not be more clear on this. This quote really says it all. Intent of Type 3.2 is not the same as true Type 3.2. They are fundamentally different, and trying to pass one off as the other isn't just bad form, it's a serious breach of compliance.
So, you have to wonder, why is getting that approval beforehand so incredibly important? I mean, having the end user agree to this in writing before a single test is done isn't just a formality. It is a critical step that has huge technical and legal consequences.
Well, there are 4 really critical reasons. First, it ensures everyone is on the same page, technically and ethically. Second, some big, high-integrity projects might have contracts that flat-out forbid retroactive validation. They want true 3.2 straight from the manufacturer, end of story. Third, the end user has to formally sign off that this specific validation method is good enough for their project's risk strategy. And finally, and this is a big one, it avoids a huge commercial risk. You don't want to spend all that money on testing, only to have the client reject the material later. Getting that written approval protects everyone in the supply chain.
And so that leaves us with one final question for you to think about. On your next safety-critical project, which level of assurance do you really need? Does it have to be proactive certification right from the mill, or will a robust retroactive validation process meet your requirements? Really understanding that distinction is the key to making sure you have both compliance and safety in every single component you use.